Stanford University.
Okay, well, welcome to lecture number 16. This time I'm going to kind of alternate between showing you some lecture slides to show you something and then doing the demo, and I'm going to go back and forth. I'm also going to go through the lecture slides really quickly because I think you'll get a lot more out of the demo showing you, and I really hope to get to all the demos. If I don't get to all the demos, like my last demo was a core motion demo, if I don't do that, I'll just do what I usually do. I'll go ahead and put the demo code in there and post it, and so you'll be able to see and look through it yourself. But it's sometimes a little more eye-opening when you see me do it. So what are we going to talk about today? I'm going to go back and talk a little bit more about NS-Timer and kind of an alternative to NS-Timer called Perform After Delay. I'm going to show you a little more sophisticated view animation than you saw. We'll do alerts and action sheets, the UI image picker controller, which is how you get something out of the camera, and then core motion. All right, hopefully we'll have time for all this. It's a lot of stuff. So NS-Timer, this is the same slide that we ended the last lecture with. I changed the last thing at the bottom because I want to make it clear that the way you stop a timer, okay, you start it by calling this factory method schedule timer with time interval, and the way you stop it is you invalidate it by sending invalidate. Okay, so that's how you stop it. That's if it's a repeating timer. If it's not a repeating timer, you don't need to invalidate it. You can see the repeating thing is that repeats yes or no. So if that repeats no, then it's just going to end and you don't have to do anything. But if it's a repeating one and you want to stop it, you send it invalidate. Okay, and if you have a pointer to the thing that's strong, you're going to want to set it to nil. If you have a weak pointer, actually it'll probably get nilled out by itself. So this is a case where you might use a nil pointer or a weak pointer besides an outlet. Okay, this timer, once you call schedule timer with time interval, iOS is going to have a strong pointer to that timer while it's running. Okay, but once you stop it running by invalidate, it's not going to have a strong pointer anymore. So if you have a weak pointer, your pointer will get nilled out, which is kind of convenient. Okay. All right, so perform after delay. What is this? So perform after delay maybe requires a little bit of thinking in your mind how this works, but it's really a very simple method. Perform after delay, perform selector with object after delay is a method, an instance method in NSObject. And what it says to an object is, please perform this selector, and use this with object as the argument. It can have no arguments, in that case with object would be nil. And perform it at some time in the future after delay. And so very simple. It executes using the run loop mechanism of the current thread. And we haven't talked about run loops, but not every thread has a run loop set up. Of course, the main thread has a run loop, and that run loop has got a lot of stuff going on, processing events and all kinds of stuff. But you can't just do perform after delay in any old thread. So for the purposes of this class, until you do more investigation, you go to a kind of more advanced level of understanding, think of perform selector with object after delay can only happen in the main thread, because you got to have a run loop. Okay? It's not real time, just like NS-Timer is not. If you say perform after delay 0.72 seconds, well, 0.72 seconds later, the run loop might be busy, in which case it doesn't actually happen until 0.74 seconds later. So it's not real time, okay? It just posts it on the run loop, and when the run loop is free after the delay expires, then it'll run it. One thing about this method, it never executes immediately, even if you say after delay 0. Okay, it always posts it on the run loop, which can be quite convenient. If you're in the middle of processing of an event and you're doing all kinds of data structure thing and you say, I want to do something like reload my view table or something like that, but I don't want to do it in the middle of all these machinations inside my data structure, you could say perform table view reload data after delay 0, and it would post it on the run loop, and after the event is finished processing, it goes back around the run loop, and then it would run it. Okay, so it's kind of a way to, an escape hatch to go run something sometime later. It's perfectly fine for the selector that you're calling with perform selector with object after delay to call it to perform itself delayed again. Okay, so it can be like repeating, right? It's a little different than timer because timer is trying to do the thing every 0.5 seconds, where this is, you say perform after delay, after the delay it happens, and then it says now do it after another delay. So there's kind of a little slight difference there, but the effect can be almost exactly the same. Just like timer, you want to make sure you stop reposting perform selector with object after delay if you go off screen, right? You don't want animations or whatever you're doing with this thing to be happening when it's not on screen. So there's the example I talked about, the table view Or maybe you might say perform reload data after delay 0. In other words, back when the run loop comes back around again. All right. How do you cancel this? So you do perform after delay, and then you realize before it goes off, I don't want that to happen. You call this class method. This is a class method, okay? Don't get confused here. This is not an instance method. It's a class method. And the reason it's a class method is, perhaps you don't have a pointer to that object anymore that you performed after delay, right? You don't have to perform it on yourself. You can perform it on other objects. And so cancel previous performed requests. You specify the message, the object that you asked to perform the thing delayed, and the selector and the argument, and it'll go and cancel it. Okay? If you say cancel previous performed request with target, just the target, it'll cancel all performed requests for that target. Okay? There is no way to find out what things are going to happen, okay? So there's no like query that says, tell me all the delayed perform things that are queued up. You just can't find that out, okay? All right, so back to the kitchen sink. What I'm going to do here is show you a more sophisticated animation, okay? And then we're going to use NSTimer and perform selector to do two different little features in the kitchen sink, so you can kind of see how they compare. So let us go over here. So this is where we left off. Actually, probably you saw from the posting that I added some buttons here so you could see how the various different modal things presented. So that's where we are. But the code is the same place that we were before. Very simple here. The only feature we have is we can add a label, right? Brings up a modal thing. We type in CS193P or whatever, adds a label with that text. And then at the very end of last lecture, we made it so you could tap on it, and it would do the animation of moving that label to a random location. And it take 4 seconds to do that. We left it with all the default animation options. So for example, it has ease in, gets up to speed, and then eases out. We saw all that behavior. So what am I going to do here for a more sophisticated animation? And I kind of hinted at this last time. We're going to make it so that any view that's in the kitchen sink is going to start spinning around and getting smaller like it's going down the drain of the sink, okay? So this is a little more sophisticated animation going on here because we have rotation and scaling going at the same time. And rotation has a little special consideration that you'll see when you want to rotate a view, what you have to think about. So how do we going to make this happen? Well, one thing is we only want things going down the drain when this view is on screen. So I'm going to put the code that causes my controller to go start putting things down the drain in view did appear. Okay? Super view did appear, of course. And so after the views appeared, now I'm going to start throwing things down the drain, and I'm going to use a timer to do that. Okay? I'm going to have a timer, and this timer is going to wake up every once in a while, see if there's any views that it can throw down the drain, and then throw them down the drain. Okay? So that's going to look like this. I'm going to need a drain timer property. So let's go ahead and create a drain timer property here. Property, I'm going to make it weak because I only need a pointer to it when it's actually running. And it's an NSTimer, and I'm going to call it drain timer. Okay, so there's that. Let's make sure one thing I always forget in these demos, synthesize. Let's synthesize our drain timer. Okay, and so then in view did appear, we're just going to create our drain timer, and we're going to use this API that I showed you, which is scheduled timer. And you can see there's a couple of different versions of this. One of them uses targets and selectors, which you're used to. This NSInvocation is a class that basically encapsulates the calling of a method. But target and selector is kind of an easier way to do that, so we're going to use this form of this. And the time interval we're going to use, let's be good and call it drain timer, and then we'll define that. And when every drain timer interval, we're going to send a message to self, and the message we're going to send is drain. Okay? The user info is an object that when the timer goes off, gets passed along. We don't need any special user info, and definitely we're going to have this timer repeat. Okay? So you can see this a little better. I will So write this out. Okay. So that's our timer. Simple as that. What is my error here? Missing square bracket. Okay. Let's go here and say # define our drain timer. And let's have the drain take about, I don't know, 5 seconds, something like that, to do the rotation. And actually, well, we'll go back to this in a second. We're going to have to modify this slightly, but we'll say 5 seconds to do the going down the drain. That seems like a reasonable amount of time. So we obviously need to write this drain method right here. So let's go do that. And actually, sorry, I'm going to do one other thing right here instead of doing it later. We're turning this on in view did appear, but we really need to turn this off when view disappears. Okay, it's really important not to have this timer trying to put things down the drain when this view controller is not even around. Okay, so I'm actually, for clarity, going to take this and move it into a method called start draining, something like that. Okay, and then I'm going to have another method called stop draining. Okay, and that one, the stop draining is just going to self.drain timer invalidate. Okay, that's how we stop a timer from going. So in my view did appear, I'm going to say start draining, and then in my view will disappear, I'm going to say self stop draining. That's super. Okay, everyone understand what I'm doing there? When I appear, I'm going to start draining. When I disappear, I'm going to stop. Very, very simple. All right, so let's look at the draining animation code, basically. And I've kind of pre-typed this here again because for time constraints. Oh, and actually I have drain duration, so let's reuse that same drain duration. Okay, so let's look at this. This is the drain, okay? This is the entire drain animation. Let's look through this line by line and see what it does. Well, it's looking at every view that is in the kitchen sink, so it's going to drain any view that's in there, any label it finds. It looks at the view and checks its transform. You'll remember that I told you UI view has a property on it called transform. The transform encapsulates the scale, rotation, it's an affine transform, so it's scale, rotation, and translation. And we're only going to put views down the kitchen sink that are identity transform. In other words, they're scaled up 1.0, they're not rotated, and they're not translated. Okay, now why am I putting this little if in here? Because once this animation starts, I don't want things that are already going down the drain to think they have to go down the drain again, because they're already on their way down the drain. And I'm going to make them go down the drain by modifying their transform, by scaling and rotating them, right? So I just don't want to be constantly doing that. So that's why I'm only going to do it to ones that are identity transform. Everyone understand that? Okay. So here's going to be the animation options. I'm going to have this animation, instead of have that ease in, speed up, and then eased out, I'm going to have it be linear. It's going to spin, the rotation and scaling is going to happen linear. Okay, it's going to not ease in and out of it. It's going to just go straight to and start doing it. Okay, so how do we do the actual animation? So here's the animate with duration, similar to the one we saw up here when we were animating the movement. Okay, but I have 2 extra arguments here in this one. Delay, which is how long to wait to start the thing going down the drain. So I'm not going to delay. I'm going to start right off going down the bat. And then options is this linear. Okay? Otherwise, it's similar to the one we had before, but instead of doing set random location for view, in other words, moving the frame, animating the movement of the frame, I'm actually animating the transform. And I'm transforming both rotating and scaling. Now, what's interesting here is I cannot rotate in one transform all the way around. Okay, and why is that? Because you remember that the way view animation works is you specify the way you want the view to be, and then you say, and take 4 seconds to go do that. Well, the problem is, if I say that I want this thing to be rotated all the way around, and I say, go take 4 seconds to go all the way around, it's going to say, I'm already all the way around. And so it'll do nothing. You see why that's happening? Because if you go rotate all the way around, then it's already there. It doesn't do it. And in fact, I can't even just go halfway, because if I go halfway, it might, when I try to animate the second half, come right back. And I want it to go around, okay, all the way around. So I actually have to do this in 3 steps. I have to go a third of the way around, a third of the way around, and a third of the way around. Okay? So you can see it gets a little tricky, this animation stuff. You've got to think a little bit about what you're actually changing. So how do I do multi-step animations? I picked this one specifically because I wanted to show you how to do multi-step animations. An animation that goes some part of the way, then goes another part, and then goes another part. And you do it with this completion block. Okay? So the method animate with duration, okay, has the animations you do, but then it also has a completion block. And this completion block is called when the animation is finished animating. All right? So in this case, when I get a third of the way around, it's going to call this completion block. Okay? What am I going to do in this completion block? By the way, the completion block will tell you whether it finished the animation or whether the animation got interrupted by some other animation happening, or your view goes off screen or something like that. So if my third of the way around animation, by the way, you see that here's the third of the way around, right? 2 pi divided by 3. 2 pi radians is all the way around a circle. So I'm going to go 2 pi divided by 3 around. And I'm going to scale from 1.0, full size, down to 70% in the first third. Then I'm going to go down to 40% in the next third, then down to 10% in the last third, and then I'm going to remove that view from the super view. Okay? So here, if the previous animation finished, the first third, then I'm just going to start another one. And this one has a very similar animation, right? It's just that I'm going to 40% instead of 70%, and I'm going to minus 2 pi over 3. Everyone know where that is on the circle, right? 2 pi is all the way around, so minus 2 pi over 3 is kind of up in the upper left. And then when that one finishes, I'll do the last third of the animation, okay, by going to back to rotate 0. See, I'm not even rotating here. I'm just doing the original transform, which is this identity transform that we got up here. So I'm going back to that, but 10% of the size, scaled to 10% of the size. And then when that one completes, I'll remove the thing from super view. Okay? I see a lot of stares. Make sense? All right, so let's watch this work. So I have this method drain. Remember that I'm starting it with this timer. I really need the drain timer only to go off every third of the drain duration, because the drain duration is going to be happening in these thirds, so it's no use starting it off more often than that, or less often than that. I want to at least start it off that often. Notice that the drain colon method, you'll remember, it always takes an NS timer. Whenever you schedule an NS timer, the selector you specify always takes an NS timer as an argument. Okay? We don't use that argument. We just call self-drain, which is this thing. Okay? Cool with that? So let's see if this works. All right, so here is our thing. Let's go ahead and add a label. We'll do our favorite label, CS193, oops, P, well, whatever, close enough. All right, so there it is. And you can see that it's rotating and scaling down and then removed. Okay? Very, very simple. And we could also, at the same time, our other animation is still in place, so let's do that one too. 193p this time. If I click on it, it'll still move and do the other animation too. Now, why can both of those animations happen at the same time? Because one is animating the frame and the other one is animating the transform. Okay, so they're not interfering with each other, so they can definitely both happen at the same time. And this is something to understand too about animations. You can fire up as many of them as you want, and as long as they're not animating the same things, they'll all happen independently. Now, if they start animating the same things, then what? Okay, so let's look at that case. So we have this thing going down the drain. What if we made it so that when you tapped on it, it saved it from the drain? Okay? How would we save it from the drain? Well, what I'm going to do to save it from the drain is I'm going to interfere with that other animation by modifying the transform. Okay? And so to do that, this is back up to our original animation, the one where we just move it to a random location. I'm going to use the more arguments 1, the delay 0, options, and I'm going to specify an interesting option here, which is UI view animation options, what's it called? Oh yes, begin. Begin from current state. So what this option means is if I start modifying some attribute that some other animation is animating, start my animation from wherever it is. If it's halfway through, start my animation there. Okay, so it kind of like intercepts that other animation and starts doing its own animation. And so what we're going to do here is, in addition to setting the random location, we're still going to do what we were going to do. We're going to set the transform, so interrupt this other thing that's going on here. And because we're interrupting it, all these finished here and these completion things are going to be no. So anywhere we interrupt it here, it's not going to keep going after that. Most interestingly, it's not going to remove it from SuperView, which is nice. So what am I going to set the transform to? Well, I could set it to CG affine transform identity. Okay, in other words, zoom it back up to full size. But actually, I don't want to do that here. Why? Because then the drain's going to go grab it right again and start throwing it down the drain. Okay? Instead, I'm going to take 4 seconds to save it from the drain by moving it somewhere else, and I want it to slowly move up close to identity, but not quite. So I'm going to set this thing to affine transform scale, almost identity. Let's go 99% of identity. Okay? So this is a little bit of a trick that I'm using here that says I'm going to intercept this other animation by changing the transform, but I'm not going to go change it to something that other animation is then going to go munch on again. However, once I'm done with my animation, then I do want to let the drain have it at it again. And so I'm going to use the completion thing here, bool finished. And when this one completes, I'm going to set the transform to be the identity transform. Okay, and once I do that, once it jumps back from 99% to being full identity, now the drain can grab it again. So I've only temporarily saved it. Okay? So maybe this will all make more sense if we see it in action. And you know, this animation stuff you're talking about, I mean, you guys are already having to deal with things happening asynchronously and other threads and stuff like that. So I know it's, if you're not used to it, getting your head around it can be hard. And animation's the same way, because we're actually changing all these things like the transforms immediately. It's just that they're taking time to happen on screen. So let's watch it happen though here. CS193B. Here it is. Now when I click on it, it's doing both undoing the other transform and moving. You see? And it's taking 4 seconds to do that. Okay? And notice that even though if it's part way through the drain, like let's say right here, it undoes it. Okay? Because it's going up to 99%. But then it goes to 100% and goes back and does this again. And now I missed it, I lost it. Okay, so now you can see the makings of a game here happening, where you can click on these things to save them, stuff like that. So hopefully you're seeing how animation can be used here. It's pretty cool. So let's go on and do one more thing. We have this drain draining everything, and it's really a pain to have to go back and CS193P. So let's add a faucet to our kitchen sink as well, and have the faucet drop things into the kitchen sink. All right, and I'm going to do that with the perform after delay thing. Okay, instead of using a timer, we'll do that. But I kind of do it in the same way, where I'm going to, in view did appear, let's say, I'm going to say drip. Okay, and that's going to start my faucet dripping. So let's implement drip, see what that looks like. Drip. So drip is going to be really, really simple. I'm just going to check to see if my kitchen sink is on screen. Okay, so if it has a window, then it's on screen. And if it is on screen, then I'm just going to add a label to the kitchen sink. I don't really have a title to give the label, so we'll have to deal with that, so I'll just pass nil. And then I'm going to perform after delay to start myself dripping again. Okay, so I just dripped, and I'm going to do perform after delay to make myself drip again. And I'm going to do that with perform selector, and the selector I'm going to do is just drip, which is what I'm in right now. With object is nil, because drip takes no arguments. After delay, and then we kind of have to have our faucet rate, so we'll call it faucet interval, say. Go up here, # define, oops, faucet interval. And let's have the faucet be adding them slightly more often than the drain is draining them. Let's say every 2 seconds. So every 2 seconds, it's going to do this. I notice I put add label down here, so let's move that up higher, right here. So it's going to call add label with nil. Now, add label with nil is kind of bad because we won't be able to see that label because it has no text. So I've created a little fun thing to add something here, which is that I created a little dictionary of colors, okay, color names and colors. And then if the text is nil or 0 length, then I'm going to get a random color, use an arc4 random, out of this dictionary, set the text to be the name of the color, like blue, and set the color of the text to be the color. Okay, so now we're going to get colored words, blue, orange, brown, dropping here in the faucet. And what about turning the faucet off? Do we need to do something in View Will Disappear to turn it off? The answer is no, we don't, because the faucet will automatically turn off when the kitchen sink is no longer on screen. So it'll just stop reposting itself, so it'll automatically turn off. Okay, does that make sense how we're going to do that? All right, so let's take a look. See how our game is. This kitchen sink has turned into a game, a video game. All right, so the faucet is already dropping things, and they're going down the drain. When they start going down the drain, I can save them. Okay, save these things, keep them from going. Maybe I could get some points for how many of these things I can keep. Oh, I'm losing red. I lost red. Okay, so click on as fast as you can. Try and keep as many as you can going. Okay. And it's kind of confusing because they're in there. Okay, so you can see the makings of a game there. Now, if I don't touch anything, they're all just going to go down the drain, except for the one dripping in from the faucet. Okay? All right. So that's it for demos for right now. Let's get back to our slides, and we'll show you another thing, and then we'll do some more demo. All right. So let's talk about alerts. Okay. There's 2 kinds of ways to alert the user. There is something called an action sheet, which is on the left right here. And an action sheet pops up from the bottom on the iPhone, or you can have it pop in a popover in the iPad. And it offers a handful of choices for the user to decide what to do next. All right? So it always has, well, it can have a destructive button, like the one called self-destruct here, that will be red, so that'd be like delete or something like that. It has a cancel button, although if it's in a popover, it doesn't have a cancel button, because in a popover you just click outside of it and it goes away. And then it can have a few other options. And then on the right is another kind of alert, which is called an alert, a UI alert. And it's more asynchronous things that happen, like you lost your network connection or something like that, that you need to alert the user. Now be careful of alerts. They are disruptive to the user. The user generally doesn't like them, so don't just be putting them up all the time to communicate information. You're better off communicating the information somewhere in your view controller's views. But if something happens asynchronously especially and you need to notify them, then you can put up an alert. So let's look at Action Sheet first. Action Sheet and Alert, very similar API, but let's look at Action Sheet first. This is its designated initializer. It's only initializer, actually. And you can see that it gets initialized with a title. That appears at the top of the action sheet. A delegate, that's how you're going to find out what the user chose. A cancel button title, okay, which is usually cancel, but it might be no or something like that. Destructive button title, that's like self-destruct or delete. And then other button titles, which can be as many as you want. It's this comma, ... notation in Objective-C where you can just put as many as you want and end it with nil. All right? So you specify all your buttons in the init usually, but you can also add them with this method add button with title. Okay, so that's kind of to dynamically add them. And then to display the action sheet, you, after you create it, you use one of these show methods on it. So there's show in view, which centers the view on the iPhone. It centers the view, well, on the iPad, on the iPhone, when you show in view, it's going to slide up from the bottom. All these are pretty much going to slide up from the bottom of the iPhone. On the iPad, it would center the view, and so you don't want that. So never use show in view on the iPad. Then there's show from rect. which is kind of cool. So you have a little rectangular area, and it'll show in a popover from pointing at that little rect on the iPad. And show from bar button item, similarly, the popover will be pointing to the little bar button item. On the iPhone, again, you only use show and view because there's none of these things make sense. You can't have popovers and all that stuff. So it's always going to slide up from the bottom. When you're displaying action sheets, you do have to think a little bit in a universal app. Okay, where, on the iPhone, it's going to slide up from the bottom, but where do I want it to come from on the iPad? So you have to give that a little bit of thoughts, a little bit of if-thens in your code if you have a universal app. So you find out, so the thing slides up, user clicks some buttons, you find out what they chose via delegate, okay? It has this method, action sheet, clicked button at index, and the index you can compare against some properties that are in the action sheet, like the cancel button index or the destructive button index, or you can get the title of a button at an index and compare that to the titles you gave it in init, okay, which is a common thing to do as well. You can also find out what the index of the first button is and things like that, so you can do some math. But usually you're just going to compare the strings. You have to be a little careful with localization there. Make sure you're comparing the string that you put in the UI to the string that comes back. And you can also programmatically dismiss the action sheet. Why would you ever want to do this, right? This action sheet comes up from the bottom on the iPhone or in a popover. Why would you want to programmatically dismiss it? Well, one of the most common and important reasons is that your application gets put in the background. Okay, why is that an important time to dismiss an action sheet? And how would you want to dismiss it? You'd probably want to press cancel. So you'd do dismiss with clicked button index, self.cancel button index. And the reason for that is when you get put in the background, you might be brought back to the foreground and your action sheet is still there. Or you might be in the background and you get killed because your phone runs out of memory, some other apps start using all your resources and you just get on the kill list and they kill you. And if you got killed right in the middle of putting up that action sheet, your app could be in kind of an odd state, okay? So kind of an auto cancel makes sense. And how do you find out you go in the background? You just listen for the NS notification UI application did enter background notification. Popover considerations, a couple of things. One, there's no cancel button. I talked about that. Two, when you have a popover action sheet come from a UI bar button, that toolbar that the bar button is in will be added to the pass-through views for the popover. And you'll remember that the pass-through views are the views on your screen that if you touch them, the popover won't go away. Normally you touch outside the popover and it goes away, but it adds the toolbar as one that doesn't happen. So that means if you have other buttons in there like our app does, has all those things to bring up a modal thing to get labels or whatever, you have to be careful then to make sure those buttons will make sense if that action sheet is still up. And even more importantly, you got to make sure that if that bar button gets pressed again, you don't get a second action sheet. Okay? So we'll show that in the demo, how we avoid that. So that's action sheet, pretty straightforward. Alert view, almost the same. You can see that the init looks almost exactly the same. There's a message, though, like network connection failed or something like that that comes in. Also, you don't have the destructive button in the alert. You can still add more buttons with this button title thing. And you display it here with show. There's no show in rect or show from bar button item or anything like that because it just comes up in the middle of the screen always. Dims the screen, it comes up in the middle. That's always the way alerts show up on any platform. And the rest of the mechanism is pretty much the same. Okay, delegate's going to get a message, told you the button was clicked. It's all pretty much exactly the same. All right, so let's go look at this in our kitchen sink. So what are we going to do? We need to have a action sheet. So I'm going to have an action sheet that comes up and has two interesting choices. One, it's going to have a destructive button, which is clear the whole sink. It's going to remove every single view out of the whole sink. That's going to be a destructive button. And then I'm going to have a regular button that turns off the drain, puts a stopper in the drain. Okay, so the drain stops happening. Okay? All right, so what's that look like? I need to go back to my UI here in the storyboard and put a button that's going to bring up this popover. So I'm going to put it right here. You see in this upper right-hand corner. So let's do that. I'm just going to go down here in my object library. I scroll mouse wheel. Where's my bar buttons? Here's one. Put this up here. I really don't want it to be next to these. So I'm going to put a flexible space in right here between these two. Hopefully you guys have maybe discovered this nice feature. So this puts it over here. And we'll call this sync controls or something like that. And so when we click this, we want to bring up this action sheet. All right, so how are we going to do that? Well, we just need to wire up this sync controls button to a target action thing. So let's do that. Let's put this down towards the bottom here somewhere, like right here. All right, so we'll put it right there. And we'll call this control sync. It had an ID as the argument there. Sorry, I'll make it so you can see this better. Control sync. What happened to control sync? Where is it? There it is. It has an argument ID, but really it's a UI bar button item. So I'm going to make that clear that this method works with a UI bar button item. All right, now let's go ahead and create the action sheet. We're going to have to go back and modify this slightly because of what I was telling you before about the pass-through views. But what does creating the action sheet look like? It's really straightforward. We're just going to say UI action sheet. Oops, action sheet, star action sheet equals UI action sheet, alloc init with all this stuff. Okay, so let's go through all these things. This is our sync control, so maybe we would say sync controls here. Okay, that's just the title of our action sheet. Delegate is self, so we're going to have to implement the UI action sheet delegate protocol. We'll do that in a moment. Cancel button. I'll say cancel, but remember that it's not actually going to appear. So even though I'm going to specify a cancel button here, it won't appear because this isn't a popover, and popovers don't need cancel buttons because you can click somewhere else and cancel them that way. The destructive button title, I'm going to call it empty sync. Empty sync. Other button titles, the only other button I'm going to have is stop drain. Well, let's just call it the drain button because I'm going to actually have that button changed depending on whether the drain is currently stopped or not. Okay, so there's that. I need to create the drain button, so let's do that. Drain button. And the drain button is basically if I have a drain timer running, then this is going to be, let's call it stopper drain. Okay, we'll put a stopper in the drain. And if not, then we'll call it unstopper. You guys know I like visit, unvisit, stopper, unstopper. So there we go. So that's the drain timer is going to say that. That's pretty much all we need to create the action sheet. We still have to do a little bit of extra stuff here to implement the delegate protocol in a second. But then we can just perform the action sheet like this, show from bar button item. Okay, that's the sender, right? Animated yes. Now, if we just did this, let's go ahead and make our UI action sheet, UI action sheet delegate. So we're going to be UI action sheet delegate, and we'll put a stub in here, void action sheet. Here are all the action sheet delegate methods. There's a clicked in, there's dismissed, did and will dismissed, and also cancel if it got canceled. So let's go ahead and do the clicked. And here's where we'll handle something being clicked. But we're not quite done up in here. And why is that? And that's because of this pass-through views thing. If control sync is called and this action sheet is already up, we do not want to put it up another one. Okay, so we would not want to alloc and init another one here. So we're going to have a action sheet property where we store this action sheet. Okay, so we're going to have to add a property to our view, and you pretty much have to do this with all popovers, is to store. Now, notice that I'm making this weak. Why am I making this weak? Because I really only need a pointer. I only even want a pointer to this thing if it's actually up. Okay, so I'm going to make that weak. So there's another example of where you might use weak, not in an outlet, right? So let's synthesize this thing. Action sheet equals underbar action sheet. Let's go down here now. Now that we have a pointer to the action sheet right here, we can check it at the beginning and say if self.actionSheet, then do something, else do all this business. Okay, now here's an interesting line of code right here. What do we do if the user clicks on that action, the control sync button, and the thing is already up? Now, a lot of you might be tempted to dismiss the one that's already up. Okay? And I'm actually a fan of that UI. I think it makes most sense that if you clicked on a button and there's a popover already coming up from that button, that it would dismiss the thing. However, the UI guidelines, I believe, and this is a little bit of a pitch to make sure you go and review the human interface guidelines that Apple publishes, especially if you want to ship your app on the App Store, because they will check to make sure you actually implement these guidelines. But the guidelines say, actually, in this case, you should do nothing. Okay? You should just not put up another action sheet, but not take the one that's there away either. All right? So we are going to do nothing. Okay? All right. So that's it. That's the only magic we have to be careful with the control sync, is just not to accidentally keep putting more and more of these up. And we had this problem too when we did the table view of favorite graphs. Do you remember that weeks ago? And I actually put the same code in there. I didn't have time to do it in class, but in the code I posted, I put in there and commented, let's be careful, make sure we don't put up multiple popovers. Okay, so the button gets clicked, right? Here we are in the delegate method. How are we going to react to that? Well, let's first of all find out what they chose. So the choice is just asking the action sheet, which is the sender here of this delegate method. We could say self.actionSheet as well here, but I'm just going to get the button title at index, the clicked index, right? Click that button index, button index. So I'm just using that button index. Now I have the string of what was clicked. And then I'm going to check some things here. Actually, even without the choice, I can check to see if the button index equals the action sheet's destructive button index. Okay? So if the destructive button was clicked, and that's empty sync. So can anyone think of one line of code I could write to empty this entire sync? It is to have our kitchen sink subviews make objects perform remove from superview. Okay, so this is a cool method on NSArray called makeObjectsPerformSelector. And it basically goes through every object in the array and makes them perform that selector. Okay? So remove from superview, awesome. There's also a perform selector with object. You can do that as well. Yeah? The question is, can I say subviews equals nil? And the answer is no, you can't do that because subviews is a read-only property on view. And you'll also just remember that the way we remove views is we ask the view to remove itself. The way we add them is we call add subview on the superview. So we've got to be consistent with that. So that's that one. What else do we want to check here? We want to see if the choice is equal to stop or drain. And here I'm going to be a good coder, and I'm not going to have this literal twice. So I'm going to change this to stop drain and make that be #define. Paste. Sorry, copy. Paste. And we'll make one for unstop as well. Okay. Now, of course you know that you don't really want to have literals, whether they're strings or numbers, sitting in your code. And why do you want to do that? Well, because you mistype them and now things don't work. Especially, though, in a circumstance like this, where I'm going to compare the choice that was made coming back to me to what I put in there. I really need to make sure I don't mistype something there, because then the logic of my program would actually be wrong. So here I'm going to check to see if this is stop drain. If it is stop drain, how do I stop a drain timer? Well, luckily, I have this method, which fortunately is not higher up in the file, but I will move it, put it up here, called stop draining, the same one I call in view did disappear. So I'm just going to say stop draining. All right, and exact same thing here. If they say unstop the drain, oops, then I am going to start draining. Okay? Make sense? So easy reuse there. And so that is all we need to do. Let's make sure this works. All right. So right now we have the faucet, it's running, it's dropping things in, but the drain is making everything go away. So if we go up to sink controls up here, we could empty the whole sink, everything's gone, okay? Or we could turn the stopper off on the drain. And so now when the faucet runs, these things won't drain, okay? Makes sense? And if I turn the drain back on, they're all going to drain down at the same time. Woo. Okay, save that one. No, let's save that one. Saved. I'm missing. There we go. Okay? So everyone got that? Make sense? Again, no cancel button in there. All right? We don't have any cancel button. If we want to cancel, we can just click outside of it. And if we click on this button multiple times, it does nothing. I don't get multiple things here. If you start getting multiple popovers, if you haven't implemented it properly, the little shadow around it will get darker and darker and darker, okay? Because all the popovers will be stacking up, all casting a shadow. It'll be getting darker and darker. Okay? All right, so that's it for Action Sheet. Question about that? All right, back to our slides. We'll be going back and forth today, as I said. All right, oops. Yeah. Okay, so UI Image Picker Controller. So this is, here, let's stop that. So this is the UI Image Picker Controller. So this is how you're going to get an image from the camera. Okay, so this is very commonly desired. I would say maybe 50% of you, your projects are doing this, which I can understand. It's kind of a cool feature and definitely gives you a little bit of breadth of coverage in your final project of iOS. So here I'm going to show you how to do it. Some of you who said this is going to be my not covered in lecture feature, and I wrote back and said, sorry. Well, this is why, because I'm going to show you how to do it today. All right, so how does the UI Image Picker work? It's very simple. It's just a view controller, and you present it using present view controller animated completion, exactly the way you would present any modal view controller. On the iPad, you can present it modally and take over the whole screen, or you can present it in a popover. Either one, you kind of have your choice. So how do you do it? You alloc init it to create it. Then you configure it, and configuring it is mostly a matter of saying what you're looking for. Okay, what do you want? Video? Do you want images? Or you just want to look in the photo library? Or do you want to get what the camera is taking a picture of? Do you want to allow the user to edit the picture they take before it gets passed back to you, etc.? Then you present it using one of the two mechanisms mentioned above. And then, surprise, surprise, you respond to a delegate method that says, here's what the user picked. So what the user can do obviously depends greatly on the device they have. Okay, some devices have cameras, some really old devices don't have a camera. Okay, some can record video, some can't record video. On the iPad, you can't simultaneously have a UI that is getting a picture from the camera or picking from the photo library. But on the iPhone, you can. Okay, so the iPad, you have to pick which one you're offering to the user. So the way you check what's available is with this class method in UI Image Picker Controller called isSourceTypeAvailable. And there's three different source types: the photo library, which is the user's library of photos, camera, obvious, and then the saved photo albums, which is a place that you can write to. Okay? Your application can put things in there, and the user could then drag them into their photo library or not, but it's kind of a staging area for you to store stuff. Remember, though, that even if a device has a camera, it might not be able to do video. And so there's a second check you have to do, which is this available media types for source type. So you pick the source type, you see if your device supports the source type, and then you ask if the media you want is supported by that source type, like the camera. Can you get video out of this camera? And there's only two source types that matter. One is image and one is movie. Okay? These are the most annoying constants in all of iOS. Okay? KUT type image and KUT type movie. Why are they so annoying? Because you have to import this completely, otherwise you're probably not going to use it, header file called mobilecoreservices.h, and you have to add a whole other framework. Okay, remember how you add core data and all that? Whoa, you have to add an entire mobile services core services framework just to get these two symbols. Not only that, they're not even NS strings, okay? They're CF strings, so you have to cast them, okay? So they are by far the most annoying things. You'll see in the code, it is really annoying. You can get more detailed even than this, you know, device and whether it's an image or movie, by talking about the front camera and the rear camera. Of course, not all devices have that, et cetera. I'm not going to talk about that today, but there's plenty of UI or API for that. So here's an example of how you would set the source type and media type. I'm not going to go through this because we're going to do it in the demo, but this is basically how you would do it. Notice the cast in the middle there for the KUT type movie. I'm casting it to an NS string. Just do it. Don't worry about CF strings. I mean, CF strings, if you start using core foundation things like CF string, there's a big issue there, which is memory management. Because you guys have ARC, okay, automatic reference counting, automatic memory management. CF does not. So when you cross between those worlds, you have to do a lot of memory management bridging. And I'm not going to talk about that because I just don't have the time in the lectures. And so in this one time that we're going to use a CF string, we're just going to cast it to NS string. They are cast interchangeable. And the memory management won't matter here because it's a constant. Okay, editability. So you're configuring this thing to, you know, a picker to show up and ask the user for something. If you're using the camera, or even the photo library, I think, you can allow the user to have a UI to edit it. Zoom in on it, move around to pick what rec they want to crop to, et cetera. And we'll see that in the demo. You can also limit the amount of data you grab with the video capture, right? Because if you are just going to do some small little video that's not going to be the whole screen or not going to be presented on an external device, then you can save yourself a lot of memory use and disk space use by getting a lower video rate capture size. There's a lot of other API in here. You can look at it for yourself, controlling the flash and all those things. So anyway, so you got this thing configured. You allocated it. You got it configured now. Now you present it. Okay? And again, there's special considerations for the iPad. You can read them up here. I talked about them earlier. After the user takes the picture, crops it if you allow them to do that, et cetera, boom, this delegate method will be called. Okay? This delegate method has a very important single argument there, which is dictionary info, and the info has all the info you need to deal with it, and I'm going to talk about that in a second. But one important thing to notice here is this is a modal view controller. You need to dismiss it. Okay? So when you get this method and you do something with the info you get back, make sure you dismiss it. And in fact, this also implements kind of the proper way. And we talked about the controversial way of whether you should cancel a modal view controller inside the view controller. This one does the right way, which is it sends you a message cancel, so you have to cancel it. Okay, you have to dismiss it. So you do all the dismissing of this thing. It doesn't dismiss itself. All right? Now, let's talk about that info. Here's the info you get back. It's a dictionary. Here are the keys that are in the dictionary, and the values are on the right, or their type of the value. And basically, you're going to get the image back. If you allowed editing, you're going to get the edited image. You'll also get a pointer to the original image, which is kind of interesting. You'll get the rectangle they chose to crop inside if they edited it. And if it's video, then you're going to get the edited video, a URL to the edited video, and a URL to the actual original video. Notice that the video is not passed back in a huge buffer or something. You get a URL to it, right? The video that someone captures is stored in your sandbox somewhere or somewhere on the disk. You don't know where, and it gives you this URL to it. Now, you can take this URL and copy it into the saved photos area or whatever. You could process the video if you want using all the video APIs, which we're not talking about probably in this quarter. But that's how you get the video back, is through the URL. There's a whole mechanism for overlaying on top of the camera, which is kind of cool. You can put your own UI on top of the image that's live from the camera. You could have your own take picture button, things like that. I'm not going to talk about that, but just know that that's there. So let's do a demo of taking a picture with the camera. So what we're going to do is we're going to allow ourselves to take a picture and put it in the kitchen sink. Okay? And it'll even go down the drain, too. So let's do that. Where is my... Oops, didn't need to do that. Okay. All right, so how are we going to do that? Let me make sure we do this right. Okay, so let's, we need a button for it, right? A button that lets us take the camera picture. So I'm going to do that right here. Hopefully we have enough room left on our bar. It's getting awful crowded. I think we have room. We'll make it a small button. Put it right there. We'll call it image. Barely fit anything else. Okay, so what does this image thing want to do? Well, it's going to have to do a target action, and that target action is going to basically present modally. Now, notice that we can't control drag into a segue, a modal segue here, because there's no UI image picker controller down in here. Okay, we might make one appear someday, but I always check to see if it's there. Nope, not there. So that means we have to do target action and present it in code, which will be good opportunity for you to see how that's done. All right, so let's go put this in here. Doesn't really matter where we put it. Put it down here somewhere, below the action stuff, below that, all down here. All right, so I'm just going to control drag in here. Okay, insert action. We'll call this add image. All right, once again, I will make it so you can see. So here's add image, target action. It's a UI bar button thing. I always like to make it clear that that's what's going on, although I don't think I'll need it here. Might though. All right, so let's just do all the things I just talked about on the slides. First, let's check to make sure UI image picker controller that the source type we want is supported. So I'm going to do the camera here. Remember, I'm on iPad, so I kind of have to decide whether this button is letting me choose from the camera or from the photo library. Now, I could have another button that lets the user do the other thing, okay? But they're not combined like they are on the iPhone. If you do on the iPhone, you'll get an action sheet, actually, that will come up first modally, and then you pick photo library or camera, and then the picker will then come up after that. So, and that happens for you automatically. You don't have to do that yourself. So we're going to see here if the source type, you can remember the names of these things, is source type available. UI image picker controller source type camera. All right, so I'm just going to see if the camera is available on this platform, on this device that I'm on. If it is, then I'm going to check and see if I can take image, right, as opposed to video. So I'm just going to say if UI image picker controller, what's it called, available media types. Actually, yeah, this is a little different. So let's do this. I'm going to get the array of media types that are available equals available media types for source type, the camera. And I apologize for all these really long names. That's just the way it is. So we got the media types. Now I'm going to see if this media types includes images, which pretty much it all does if it's a camera. But I'm just kind of showing you this to see how this works. So media types contains object, NSString, KUT type image, okay? So if it contains the image, then we continue. If it doesn't, we can't. So now we got an error here because this is not defined. So now watch closely as we go through the process to define this. All right, first thing we do is we go up here and we import, and it's not going to help us type this, mobile core services / mobile core services.h. Then we're going to go over here to our target, to our build phases, add a library here. Core, we'll search for mobile core services. There it is, and add that. I almost guarantee you'll forget to do that, and when you run, it's going to say, oh, KUT image not defined, and so hopefully you'll remember back to this day, or look at the slides, because the slides also tell you what to do. All right, so now we've got KUT in there, and we've put this NSString cast in here, even though you don't really probably understand what that's about, and I don't blame you. But that's what we're going to do anyway. So now we're ready to actually create our image picker controller. Okay, so I'm going to call it picker, and I just create it with UI image picker controller alloc init. Simple as that. Most important thing I need to do is set myself as the delegate. All right, because otherwise I'm not going to get the message. Now, another quirky thing about this API is that the UI image picker is a UI navigation controller. And so UI navigation controller has a property called delegate as well. And this is kind of it's using it for both things. So when we go up here to say that we implement UI picker controller delegate, UI image picker controller delegate, we also have to say that we're a UI navigation controller delegate. Okay? Now you're not actually going to use anything in that protocol, but it's just kind of an unfortunate, possibly unfortunate decision that they decided to have the delegate be the same named property, so that delegate has to implement both of these, say that it implements both of these. All right? So that's in the slides too. So if you have trouble there where it's giving you a warning here saying, you know, this self is not a UI navigation controller delegate, you'll know why. All right, so now we got to set up the source type that we want, and remember that we want this. Learning my lesson, not so much typing. I also need to set up the media types that I want. So that's an NS array, array with object, NS string, KUT type image. Okay, just do it. So that's the media types. I'm also going to allow editing, so I'm going to say allows editing equals yes. And I think that's all. And so now I can just present. So I'm going to start by presenting it full screen, modally, not in a popover, just so you can see what that looks like on the iPad, because it's kind of cool. So I'm just going to do present modal view controller, the picker, animated yes. Okay. Now I need to implement the image picker's delegate methods here. So that's image picker, let's do this one first. This is the one where we actually get the information. Okay, did finish picking media with info, and we'll do something there when that happens. And then we're also going to have image picker controller did cancel. Okay, and both of these I'm going to have a little method called dismiss image picker. I'm going to call it from both. And you'll see why I separate this out in a second here. Void dismiss image picker. Now, for this, we're not doing popover yet, so for just the normal modal view controller, all I need to do is what I would normally do when I'm dismissing a modal view controller is self, because I'm the presenter, dismiss modal view controller, animated yes. Okay, if this is a popover, I'd have to dismiss the popover here. Okay? All right. So the last thing we need to do is do something with the image. We got this image. What are we going to do with it? And it's pretty straightforward here. I'm going to get the image from the info. So the info object for key. And the one for that is UI image picker controller edited image. So that's the edited image. But to make my code a little bit more general, even though I know I'm offering them to edit it, if I ever set this to no, I would still want my delegate to work. So I'm also going to say if not image, in other words, if there's no edited image, then I'm going to set the image into object for key, the unedited image, original image. Okay, so I'm just being a little more general there. So if one of those two is non-nil, okay, so hopefully we get something, then I'm just going to create an image view, UI image view, alloc init with image, the image. So I'm creating an image view. One thing I don't want this image view to be, though, is gigantic. You know, some of these devices have very high resolution cameras, and they'll give me very big images, okay? But here is the kitchen sink. I want the thing small. So I'm going to put a little code in here to make that thing smaller. I'm going to get the image views frame. And then I'm just going to keep going half as big all the time until it is, let's say, okay, while it's greater than the max image width that I'm going to allow, I'm going to say frame.size.width divide equals 2 and frame.size.height divide equals 2. So I'm just going to keep making it half as big, half as big, half as big until it's under some max image width, which I'm going to pound sign define to be, you know, maybe 200 pixels is good size. Okay. And then I got to set the image views frame to be that. And then I'm going to put it at a random location. And then I'm going to add it to the kitchen sink. Okay, questions about that? All right, let's see if it worked. Okay, so here we have our sync is working, looks like. So let's click on this image button on the bar, and when we click on the image button, it's going to load up modally, full screen modal presentation, the camera. So here we have the camera. We can look around. Let's take a great look at our little HDMI converter box right here. Okay, and I'm going to hit take picture. Now notice that I can edit the image. I can zoom in and out. I can almost read the words on there. Okay, pick whatever I want. I could retake the image. That's the lower left. But I'm going to use this image, and there it is. And it even goes down the drain. Okay, and I can even save it too. So let's go back and take a picture of something else. I don't know. Maybe the whiteboards here would be good. All right, whatever. Use. And if I click on it, I'll save it. Okay, just like I can save the text. Okay? Make sense? It's because it's just a view, and all this view animation we did was totally view-centric. Okay? Any questions about that? All right, I'm going to, all right, well, we have a choice here. I can do the slides only on Core Motion, or I can show you how to do the image picker in a popover. Okay? So if you want me to do Core Motion, raise your hand. Okay, if you want me to do this thing in a popover, raise your hand. Okay, Core Motion wins by a hair. Okay, so I'll show you Core Motion. And this is probably better anyway, because I will post this code after lecture, and I'll put in the Core Motion example. I'll explain what I'm going to do with the Core Motion is. I'm going to make it so that as you tilt the iPad, the views slide down towards where you're tilting it, okay? So they slide towards the center of the earth, basically, okay? At the same time, they're doing all this other stuff too, okay? So like if you click on one, and it starts to move over here, and you tilt it here, it'll actually start fighting gravity and then sliding back, which is kind of cool, okay? So, and the code for that is 5 lines of code, so that's the other cool thing. All right, so let's look at Core Motion. So what is Core Motion? Core Motion is an API to access all the motion sensing device hardware. And there's quite a bit, right? You've got accelerometer, gyro, and magnetometer as well. So if you have an accelerometer which tells you how fast the device is accelerating in space in 3 dimensions, okay? And a gyro which tells you the rotation basically of the device in space, and a magnetometer which tells you where north is, you can find out an awful lot of information of where this device is in the universe, okay? Especially relative to where it was a few seconds, or a few milliseconds ago, right? You can, relative motion especially, you can kind of see what's going on, but not even just relative, also real motion, real, because you can also throw GPS in there. So if you use GPS, the magnetometer, gyro, and the accelerometer, you know a lot about where this device is. But unfortunately, not all devices have all that hardware, okay? Some of the devices, older devices, maybe only have the accelerometer, for example, and only the newest devices have the gyro. So just like we had with the camera picker thing, we need to go and find out what it has, what our device can do first. And the way we access all the information about the motion is through this class called CM Motion Manager. Okay, this is the magic class that's going to tell you everything about what's going on motion-wise. Now, you create it with alloc init, but you really don't want to create more than one instance of this, because if you start asking for this information at different data rates and stuff, your performance will really suffer. Okay, these devices like the gyro and stuff, they can't necessarily give you their information on demand without any cost. They use battery and things like that, and so really we're only going to want to have one motion manager. So in the demo code that I'm going to post after lecture, I actually am going to create a category on CM Motion Manager that has one class method in it, which is Shared Motion Manager. And then I'm going to use that category to get the Shared Motion Manager and use that one throughout my entire app. So this is one case where you do want to use a global. Why? Because there's only one set of that hardware on your device. Okay? You don't have multiple sets of hardware. You only have one. But what it does mean is that the data rate at which it's reporting things, really you can only set it for one user, one object in your application at a time. Okay? So how do you use the Motion Manager? You first check to see what hardware is available, just like the camera, and then you either start sampling, you tell it to start getting the data, and you start looking at it by basically polling or asking it, or way better, you post a block onto a queue, and that block will be called at whatever data rate you tell it with the latest status of everything. Make sense? So those are the two ways to do it, polling and getting a block called. So how do you check the availability of the sensors? They're very simple. In CM Motion Manager, there's these properties, accelerator available, gyro available, magnetometer available, device, et cetera. There's an interesting one there. You see the last one called device motion. And we're going to talk about what device motion is because it's kind of a combination of all the other ones. Then you can just start it running. Okay, you start whatever hardware you want running by saying start updates. And you can also find out whether the CM Motion Manager is currently collecting data from a particular hardware device by asking it whether it's active. When you're done, you want to stop it. Okay? In fact, you want to use this stuff as little as possible because it's not cheap. Okay? It uses battery, basically. So do not leave these things just running in the background if you've got a view that's not actually looking at the information. All right, so here's how you would poll the data. Basically, you call a method like accelerometer data on the CM Motion Manager, and it'll give you the latest accelerometer data. And here's a whole bunch of stuff about the various data formats for all the things, the magnetometer, the gyro. And then device motion, which is the only thing we're going to talk about really, is the intelligent combination of those. Now, all this information you get above, like the gyro and the accelerator, is kind of raw data. So for example, in the accelerometer data, that doesn't include it includes acceleration due to gravity. All right? So if you're trying to figure out which way your device is moving, accelerating during space, you have to deal with gravity being in there. Gravity is 1g down, right, towards the center of the Earth. I'm actually using that in my app. I want to know where gravity is because I'm making my things go towards gravity. But in other apps, you might not want to. You want to know the relative acceleration, and you want to factor gravity out. Well, you can't really factor gravity out very effectively unless you have a gyro or a magnetometer. And if you do, then you can start using this thing, device motion. Instead of using accelerometer data, you would use device motion. So here, for example, in a device motion object that you would get from CM Location Manager will give you the user acceleration and the acceleration due to gravity as separate vectors, which is really cool. Okay? So it gets rid of all the device error, you know, it can clean up a lot of that, and it can separate out what's gravity and what's not because it has this gyro basically, so as you turn it, it knows. Rotation data is even more interesting, right? Normally a gyro, you kind of get this raw data and it's not really telling you what you want, but with a combination of having the accelerometer and the gyro, now you can get roll, pitch, and yaw. So you can actually know what your device is. You know, if you imagine your device was an airplane, right, you can tell roll, right, pitch, and even yaw. Okay, so a lot more information if you combine the two. And the core motion combines it all for you. So you don't have to do any of the complicated math behind doing that, which is quite complicated. Totally understood math, but still complicated. Core motion will do all that for you. So here, how do you get this information? You do it by registering a block. Here is accelerometer and gyro and magnetometer. And here is device motion. So here's getting the device motion updates. Only thing to notice here that's kind of interesting, notice that the way you specify the queue is you don't give it a dispatch underbar Q underbar T. Okay? You give it an NS operation Q star. But an NS operation Q star, it's basically the same thing as a dispatch underbar Q T. It's just like an object-oriented version of that. And 99% of the time, you're probably going to be specifying the main queue as your queue. That's what we're going to do here. We're going to do it on the main queue because I need to do UI stuff when my accelerometer changes anyway. But you could specify another thread, and the way you do that is just NS operation queue alloc init. That's just like dispatch queue underbar create. Okay, now you have another queue, and you pass it here, and it'll execute this stuff in another thread. But be careful not to do UI stuff there, or managed object stuff, or whatever. Yeah.
With the NS operation queue, do we have to worry about releasing it at some point?
So the question is, do we have to worry about releasing the NS operation queue? No, you have Arc. Okay, so it'll take care of all that for you. In iOS 5, they've added these reference frames to give you even more specification of where things are in space with device motion. I'm not going to talk about that, but if you're really into where the device is exactly in space, then you might want to look at this reference frame stuff. You can obviously specify the interval at which your handler, your block, is going to get called. Okay, so this is in number of seconds, right? So if you wanted 50 hertz, this might be 0.02 seconds. Again, you don't want to do something too expensive in that block because, especially if you have a high data rate, same reason that we have with the timer. And it is okay to add multiple handler blocks. In other words, you can call start accelerometer updates with this block, and then you can call it again, start it with this other block too. So you could have two different blocks going on, but they all will share the same data rate. Okay, and this is where having a shared CM motion manager can be somewhat possibly a disadvantage, but it's intentional that you only want to have one because you really don't want it reporting at different data rates unless they were an exact multiple of each other, one at 25 hertz, one at 50. That would probably not be bad. Okay, so we don't have time for the demo. We're 5 minutes over anyway. I will post the code that makes this thing tilt. I encourage you, one thing about the kitchen sink app that's nice is you can see it kind of has the makings of a game. And you could imagine adding a score thing and all this stuff. And so hopefully this will give you some inspiration this week. We'll give you some inspiration of other features you might add to your final project. Even if you've gotten your proposal approved and it's got good scope, it's always nice to throw a little more breadth in here and there. Okay, so that's it. Have a good Thanksgiving. Don't forget the Friday section tomorrow. It's going to be great. And I will see you the week after Thanksgiving.
For more, please visit us at stanford.edu.